All right, Honors Pre-Calculus, Semester 2 Final Review. This is for the performance portion of our final. Again, we're going to hit a few of the problems that are similar to those that you're going to be seeing. You already know the list. Again, you've been doing the prep work the last few days. We've been talking about these types of problems throughout the week. So jumping right into it, first problem we want to take a look at. If we take a look here, the directions say to complete the following without a calculator in preparation for the final. So number one is telling us to graph and identify the period, amplitude, asymptotes, the domain, and the range. So if we were to begin a problem like this, and obviously we can see that it's a trig function that we're going to be graphing, where we need to begin is with identification of A, B, C, and D. So A in this problem is going to be 3, the coefficient in front of our trig value, or trig function, excuse me. B is going to be 1, the coefficient in front of our x term. C is 0, that's the amount that's being subtracted from x within those parentheses. And then D would be -2, the amount that's being, in this case, added or subtracted from our entire sine function. So once we know A, B, C, and D, we can now use this information to start to make some judgments on the rest. So even though it's not specifically spoken about as part of our answer, we're generally, within our class, where we generally begin this problem is to determine whether or not there's going to be a reflection. So I'm going to go ahead and make a note here that there is no reflection. And the reason that we know that is that when we look at our A value, if A is positive, it's not being reflected. If A is negative, it's absolutely being reflected. So as we go on, the next thing, and this is one of our answers, to identify the amplitude, it's just simply the absolute value of A. So the absolute value of 3 is 3. So we have that. Excuse me. Next, we're supposed to identify the period. So the period, this being a sine curve, whether it was sine, cosine, secant, or cosecant, we're going to take 2 pi divided by b. So in this case, we said that b is 1. 2 pi divided by 1 is 2 pi. So we have the amplitude, we have the period. Again, we're supposed to comment on any asymptotes or anything like that. The fact that this is a sine function, that's going to pretty much take care of the fact that we do not have any asymptotes. So asymptotes here, I'm just going to go ahead and write none. Again, these are my answers, but the other thing that we're going to need, not, again, an answer per se, but we need to identify our starting point. So the way that we've always found the starting point is that we're going to take C over B, comma D. So this is what we're looking for, is we're going to put, again, with our variables that we just found, we're going to put C over B. So in this case, C is 0, B is 1, so 0 divided by 1 is still 0, comma D, which is -2. So the moment we have our starting point, understanding what we're really going to be doing is we're going to attempt to build a frame. We're going to go framing method in order to complete this. So my starting point, again, we're going to consider that we're about to move the origin. So just kind of off to the side here, so we're all thinking, I'm going to sketch out the parent function for sine, and the keys that we want to identify is that we're absolutely going to be going through the origin, and I'm going to start up to come back down. So again, very roughly sketched in, that is our parent function. So we're going to have to match that, but in a different location. So I know that my starting point is going to actually be moved to 0, -2. It looks like the amplitude is 3, so I'm going to count up 3 and down 3, which I'm now regretting making the graph the size that I did. And then we're going to move to the right 1 period. So if the period is 2 pi, I'm going to go all the way over to 2 pi. And I'm going to come down to complete my frame to look something like this. Once we have the outer frame sketched, we're going to cut it in half horizontally, and we're going to split it into fourths vertically. So I cut it in half, then I cut each of the halves in half. So once we have this frame with the 8 congruent rectangles, now we just consider that, yes, this starting point, that is attempting to match this origin. So what we're trying to do is we're trying to look at the parent function, and we're going to try to make that sketch fit. So remembering, of course, that there was no reflection, that means that I'm still going to be increasing through the origin or increasing through my starting point. Had there been a reflection, we just wouldn't have increased, we would have decreased. So this is going to be my sketch. Again, going back to the beginning of this problem, We're supposed to identify the period, the amplitude, done. Asymptotes, we said that there were not any. And then finally, the domain and the range. So as far as the domain is concerned, excuse me, as far as the domain is concerned, there are no asymptotes. So this is going to, again, this is one period that we've graphed, but this is going to go from negative infinity all the way to infinity. As far as the range is concerned, remember that we always go from low to high. So the lowest possible value is -1, or I'm sorry, -5. The highest possible value, or not negative, but positive. I get my answers right here. But again, both the -5 and the +1 are included. So for that reason, we have our domain and range. The last thing that we might be asked to comment on would be the identification of our key points. So as far as identifying these key points, it looks like our first point is at 0, -2. Let's see, the next was at pi over 2, comma 1. Next, we're at pi -2. Next, that way. Next, we appear to be at 3 pi over 2, -5. And then finally, we're at 2 pi, -2. So again, these would be our key points. Again, we might be asked to comment on something of that nature. So again, that was our sine curve. Again, if you can do sine, you can do cosine, you can do secant or cosecant. Again, really, I think I'm confident that we can be successful there. Second problem that we want to take a look at, again, the directions you'll note are pretty identical. We want to graph and identify the period, amplitude, asymptotes, domain, and range. This time, as you can see, we have a tangent function that we're going to be graphing. Within the problem, it says that we only want to graph one period. We should probably go back. Yep, previous problem didn't say one period or two periods, so we're happy with one. So for this particular problem, we're actually going to begin the exact same way. We need to figure out A, B, C, and D. Even though it's a tangent problem, we're going to do a lot of things differently because it's tangent. But this is actually one spot that stays the exact same. So for my tangent function here, A is 1. Lead coefficient in front of the tangent is 1. So B is also 1. It's the lead or the coefficient in front of the x. Excuse me. C in this case, this is again the amount that's being subtracted. Hold on. I need to get my story straight here. B is 1/4. I almost screwed that up. Sorry about that. Again, we could rethink this problem as being written as y is equal to the tangent of, if it's x over 4, that's got to be considered the same as 1/4 x, like that. So again, please don't make the mistake that I almost just did. Again, we need to consider that b is 1/4. C, the amount that's being subtracted from my x term is 0. D, the amount that's being added or subtracted on the outside is also 0. So again, we can confidently say now that A is 1, B is 1/4, C is 0, D is 0. Just like before, let's take this opportunity to consider whether or not there is a reflection. I'm noticing that A is positive, so there is no reflection. It's written up there, no reflection. Next, we always go to the amplitude. Now, I'm going to go ahead and put some quotes around that because, again, tangent doesn't have amplitude. So if we're answering the question, again, if you were to see something like this on your performance portion of the final, if it's saying what is the amplitude, we would say none, because again, this does not have amplitude. Now, what we're going to do, and I know that this is confusing. Again, this is an answer right here. That's part of the solution. But what we're going to do is we're going to find, again, it's not really the amplitude, but it's going to help us to build our frame. So our quote-unquote amplitude is going to be 1. But please understand that if you're asked what is the amplitude, we have to say that it does not exist. Because a tangent function, and we'll talk about the range here in a couple of minutes, but the tangent function, it's going to go vertically from negative infinity to positive infinity. The amplitude stretches vertically. So it's not like we're stretching it more or less. And again, if we're already infinite, we can't increase that even more. So something to consider. Next, taking a look at the period. Remembering that this is a tangent problem. If it were a sine like the previous problem, we did 2 pi over b. If it's tangent, we're just going to look at pi over b. So when we look at pi over b, that means that we're looking at pi over 1/4. So when I'm dividing fractions, I multiply by the reciprocal, and pretty quickly we're going to realize that 4 pi is our period. So that lengthens things out significantly. But again, that is our period. So again, we're asked to identify the period, done, amplitude, we talked about that. The asymptotes, we'll get to that here in a minute. But if we're going to sketch in the asymptotes, we should probably have a pretty good idea first of what the sketch is going to look like. Again, as soon as we build our frame, we will know our asymptotes. So speaking of the frame, in order to do that, we're going to have to find our starting point. So just like all the other trig functions, we're going to go with the starting point being c over b, comma d. So c is 0 divided by b, which is 1/4. 0 divided by anything is going to be 0, comma d, which is also 0. So again, this is not an answer, but what that does is it solidifies the fact that we're not moving horizontally or vertically. We already know that we've altered the period, but we're not stretching vertically at all, but we're going to stretch this thing horizontally. Again, we're making the period last longer, significantly longer, like 4 times longer, in fact. So all of this being said, now we can go ahead and start building our frame. So my starting point is going to remain at 0, 0. So my job when building the frame is to go up and down the amplitude. Again, it's not real amplitude, it's kind of, I hate to say it, but fake amplitude. We're going to go up 1 unit. So just so we can, no, we're fine. We're fine. I was gonna say let's extend this out, but I don't want to confuse anybody. So once we've gone up and down the amplitude, again, sine and cosine would say that we would want to move to the right 1 period length, but that's not what we would do with tangent. Instead of tangent, we're going to go to the right half of the period. So half of 4 pi is 2 pi. We're going to go to the left half of the period. This way, my starting point is smack dab in the middle. Once we have that outer frame built, it's the exact same. We're going to cut it in half horizontally, like this. We're going to split it. It's already cut in half vertically, but then we need to split into 4. So once we have this sketch drawn in, now we need to consider what it is we're looking at. Probably should have started here, but if we're to consider the parent function, f of x is equal to the tangent of x, the way that this is going to look, and the keys that we're supposed to remember is that from the origin, or through the origin, it goes through the origin in an increasing manner. So my starting point is nothing more than my new origin. So we're going to be increasing through the starting point. Okay. We know that we're still increasing because there was, again, as we said, there was no reflection. So in terms of the asymptotes, by sketching in this frame, we've already done it. The outer edges, my outer walls, or I don't know, whatever we want to call them, but these are going to be our asymptotes. So hopefully you can draw straighter lines than I can. So my asymptotes, looks like we have one is at x equals negative 2 pi, a second appears to be at x equals positive 2 pi. So we've figured out, again, the period, the amplitude, the asymptotes, and we're continuing to build that sketch. We know that we're going to be going through the starting point in an increasing manner. So the reason why we cut into these forces, we now know where the other points are going to live. So when I'm building my sketch, it's going to look something along these lines. Okay? So a few other pieces that we're asked to complete here. We're supposed to comment on the domain of the range. So the domain of this problem, and I think I told you guys this yesterday, we're not going to ask you for the domain on a tangent because it's not that you can't do it, but it's just going to be really hard to figure out. Again, the way that we would actually have to do it is we'd have to say something like, yeah, x could be equal to anything except for if you had 0 plus 2 pi. Okay? That means that every 2 pi, we're gonna slap another asymptote up there, and that's going to cause a problem. Okay? So again, not that you will absolutely not be required to be able to handle that or do that. Again, I'm not worried about your knowledge of that. I am absolutely worried about your range because we're going to be going from negative infinity all the way up to infinity. So that's absolutely part of our answer. Last, if we wanted to go with some key points here, some key points, looks like there's only going to be 3. So again, I'm running out of time. So negative pi, negative 1, 0, 0, positive pi, positive 1.